So here I'm going to talk about 5 main summary statistics that I use in my data analysis classes. A lot of times I have students who haven't taken any statistics at all, and sometimes it just helps to have a little bit of a refresher or to see like kind of what the underlying concepts are behind these statistics. So I'm going to show you with how to do it in Excel, but I'm not going to use the mathematical written formulas. I'll kind of explain why the formulas are used and what they get at, what they try to do. But I'm going to start off by showing you some data that I generated to kind of give you the point of why we do this. All right, so these are 4 data sets. I basically generated 50 observations using R, and these are normally distributed around a certain point. I made these using just a random formula. And I'm going to show you kind of 3 scenarios and a 4th here with one change. And we're going to get at what the statistics tell us, okay? And so the 5 statistics we're going to use are the mean, median, standard deviation, minimum, and maximum. All right, I'm going to introduce a 6th one called the coefficient of variation, which is also useful, but I'm going to do that a little bit later. All right, and so what we get at with these summary statistics are 2 things. One is the center, which is basically where the data are located. What's the central point? What's the middle of the data? Okay, you can see that of all the points I generated, and these are all the values that I have. From here, it's from 96.3 to 105.03. Right around in the middle, right around 100 is that middle point. Okay, that's the first thing, is the center. Second thing is a measure of the spread, right? How far out they go in either direction. Now, you could get the minimum value, right, and the maximum value, but that's just one point. You could have a whole bunch of points around the minimum, you just get one minimum, one maximum. And so what statisticians generally do is they use the standard deviation, okay? And what the standard deviation does is it looks at each point, and it takes each point's distance from the center, and that's what's used in the formula. Okay, so the mean is the average, right? A lot of people know the average. You add them all up, add up all the values, and you divide by the number of observations. And then there's the median, right, which is literally the middle point. Now, if you have an even number, there's 2 middle points. An odd number, there's 1 point, right? So next I'm going to have 11 observations, and the 6th is in the middle of 11. There's 5 before, and then the 6th point and 5 after. But if you have an even number, you actually take the 2 middles. All right, here there's 50 observations, so 25 and 26 are both the middle. You just average those, okay? And then minimum, the easy thing, like the simple way, is you sort and just take the lowest value, all right? And then the maximum, you could sort and take the highest value, but we'll do all of these in Excel next, all right? And then standard deviation, there's a formula that I'll show you, okay? And just to get at what that is, basically each point has a distance from the mean. All right, and then you can take that and you can, what we're going to do is we're going to square it, okay? And the reason why we do that is because this is negative and this is positive, and they don't cancel out, okay? This is a big positive, this is a big negative. And what squaring the numbers does is it does 2 things at once. One, negative numbers, if you square them, become positive, all right? So this distance is equivalent to this distance when they're both squared. And the other thing standard deviations do is if you have big distances, big deviations, then you actually square it. It becomes even bigger when it's squared. So large deviations are penalized. They make large standard deviations. Okay, a couple examples I always give are GDP growth rates or house prices. You could have a mean growth rate of 3%. Some years it's 2, some years it's 4. If you look at all the years, you can look at the standard deviation, figure out how typical it is to have values that are further low or further high. Same thing for house prices. The average house price in a neighborhood could be $300,000. Some could be $200,000, some could be $1 million. The standard deviation takes in all the houses, figures out one number, and it gives you a sort of a yardstick or a standard measure of how typical it is for a value to be below or above average. Okay, and so instead statistical analysis, basically if you're 2 standard deviations from the mean, that means you're significantly far from average. All right. One thing about the standard deviation is that it is measured in the same units as the thing you are measuring. So a GDP growth rate of 3% could have a standard deviation of 1%. All right. A house price of $300,000 could have a standard deviation of $100,000, right? So it's a measurement that's in the same units as the thing that you were measuring. Okay, and so I'll show you this in Excel, but basically for the standard deviation, you take each distance, square it, add them all up, and divide. by the number of observations. And that gives you, and then it gives you the variance, and then you take the square root of that. Okay, here's a simple set of data that I made here, right? This is a really one high value. There's a bunch over here, but when you take the mean, it's right around 100, and the median is very close to that. That means that the high and low values, in a way, cancel out. Okay, but what I did was I took this high value, which was 105, and I made it 150. Okay, so I just changed this one value, and I want to show you something. This value changes 3 of the 5 values. Okay, so the mean goes up. You introduce one really large value. Sometimes this is called an outlier, and it's going to pull the average up. Okay, so sometimes people talk about like if 3 people are in a room and then regular income people are in a room and a billionaire walks in, it's going to pull up everybody's average income, right? Because you're taking $1 billion, you're dividing it by 4. Everybody's has $250 million. But what the median does not change at all, because the middle value doesn't move, right? This only changes one top value. If this is the exact central value, that did not change. The median is less sensitive to outliers, okay? And so that's why we use it sometimes when we're talking about distributions like income or house prices, test scores. If you have one A+ student, they don't pull up the average and ruin it for everybody else. So the mean goes up, but the median does not. Standard deviation goes up because now you have a big distance to square into using the formula. The minimum value didn't change, but the maximum did, because that's the one change I introduced. And you can see here that I've got 2 lines here. The median is this line that's a little bit thicker. It's the same, but the mean got pulled up. All right, and the rest of the data are the ones over here, but they're far separated from this one outlier that I made. Right down here is a new data set. It's got new numbers. Because the median's the mean's about 16 and the median's a little bit higher. Standard deviation is 4. There's a little bit more spread to it. And then the minimum and maximum are given based on these 2 points. Right. So if you look at the data, you can find the middle is somewhere around here, but the formulas tell us what they are. Right, mathematically, and that's one important thing. If you've never taken statistics before. This is what I call eyeballing it. You just look at it and you say, it looks kind of spread. Oh, it looks like the middle's around here somewhere. Well, the math gives you a specific number, and that's actually the whole point of why we use statistics. The math gives us a specific number for what the center is and what the spread is. Okay. Finally, over here, again, the mean and median are around 8. Standard deviation is really low. The coefficient of variation actually looks at the ratio of the standard deviation to the mean, and it kind of controls for the fact that large numbers might have large standard deviations, and you just divide that out. All right, but the minimum and maximum points are here. Standard deviation is about 1. All right, so different data sets have different summary statistics, and you can use those to describe the data that you have. What is the center? What is the spread? And like I hinted at earlier, people use this for statistical analysis. They say, well, this is a really high number, and they talk about significance. Is it significantly high? Is it so high that it's abnormally high? And the standard deviation is like your measure for what's typical or what's normal. And so basically, this standard deviation says that it's normal. It's typical to be 1, maybe 1.5 standard deviations from the mean. So if the average is 100, if you have 102, that's typical, right? You're within the realm of what you would see naturally. 103. Once you get to about 2 standard deviations, which here is about 104, then you say, wow, these numbers are higher than would be normal, higher than would be typical. And then you might say that there's something going on that is not explained by random chance. And so this point, especially, and probably also maybe this one, are so high that there's something else going on. And if you're testing a hypothesis, you would basically say that this isn't just random. This might be because of the thing I'm looking at. And that's where we get into statistical inference, right? 2 standard deviations above the mean. But for right now, you're simply taking some data and you're looking at where's the center and how do you define the spread. And so the mean, or the average, is the one way. The median is the other way. That is more, they call it insensitive or robust. It's insensitive to outliers. So this point doesn't change the median. So now we have 2 measures of center. And then the main measure of spread is the standard deviation. Okay, so let me show you this in Excel. right? I've got three cases here, right? I'm going to show you they're all based around 2. They have an average of 2, but they have different amounts of spread. Okay, so case 1, literally they're all 11 observations. And here in case 1, literally all 11 are 2. So it's 2, 2, 2, 2, 2, 2, 2, 2, 2, 2. That's all it is. And so you say, well, the average is clearly 2, right? And the median's 2 because the 6th observation, which is directly in the middle, is 2, right? There's nothing surprising here, but there's no spread, right? There's no deviation at all. And so the standard deviation is going to be 0. Okay, the minimum is 2 and the maximum are 2, which is also no surprise. So it has an average of 2, but literally nothing else going on. Now in these cells, I put the formulas in Excel. If this is new to you, you can see it or try it on your own numbers. And this goes from A7 to A17. All right, and this is the Excel formula for that, right? So the equal sign, average. So you use average instead of mean. So to type it in correctly, it is average. And this is the range of cells. Right, you can do the same thing for median, standard deviation, and so forth. So if you look at it in Excel, you'll see the code in the cells. Okay, now that's case 1, which is less surprising. Now in case 2, you've got a little bit more spread. So here's 2.1, which is above average, and here's 1.9, which is below average. And you think, well, don't they cancel out? When you square them, that disappears. And for these two, I did the same thing. This is +2, and this is -2 from the average. And they don't cancel out either. And they're going to be larger deviations and they're going to be larger squared deviations. And the rest is kind of random. These are above, these are below, this is above, this is below. And this is on average. Okay, so this is 11 more observations, but they have a little bit more spread. And the way I worked it out, the mean is 2, median is 2, and again, the formulas are in the cells if you look at it. But the standard deviation is not 0 anymore. It's going to be a little bit larger, and I'll show you the formula next. Minimum and maximum, you can look, the lowest is 1.7, highest is 2.3, but Excel has a formula too, okay? Now, you can do this by hand, and so I did this, I took the sum down here, which is just add them all up. You get 22, and then divide by 11, and you get a mean of 2, and that's doing the formula by hand, okay? Now, what I'm doing here is I've got a couple cells, oops, and I'm going to unhide them. And this is kind of how you do the standard deviation by hand, okay? So what I did here was I took every value -2, right? So 2.1 minus 2 is 0.1. 1.9 minus 2 is -0.1, and I do that for all of these. This is all the distance from the mean. And I've got this in here as a frozen cell. You can see the $sign if you work on this yourself. All right, but this is the deviation minus the mean that's calculated over here, all right? And I square it. So 0.1 squared is 0.01 squared, and so forth. 0.2 squared is 0.04, so it's larger, right? So it's larger deviations get larger squares. So I take the deviation, then I square it here, and then down here there's no deviation at all, all right? So there's no deviation, so 0 squared is 0. Down here, I add them all up. So this is the sum of all these here. Add them up into one number, and again, I've got the Excel formula in the Excel file. And then once you have that, you divide by the number of observations. Okay, so the number of observations is 11, and there's 2 ways to do it in Excel. And I always do what's called the population standard deviation. I divide by n, but probably a lot of ways maybe people prefer is to divide by n minus 1. Right, so here you could divide by 10. All right, and so that's, if you see in the formula, you divide by either n or n minus 1, and you can see it in the formula. I use the P version for population. All right, so once you take 0.38 and divide by 11, you get 0.03455. This gives you something called the variance. Okay, the variance is basically the sum of the squared deviation, or the average of the squared deviations. Okay, now that is used a lot in statistics, a lot in econometrics, but for right now, all we're going to do is we're going to take the square root of that, and you get the standard deviation. So the square root of the variance is the standard deviation, and so that's where we got this number here, 0.18586. I did it by hand, right? I've got my observations, minus the mean, square everything, add them up, divide, get the variance. Take square root, get standard deviation. Now, if you do the other version, you get this other standard deviation, which is the sample standard deviation. Basically, you turn one into the other. All you do is you multiply by the ratio of n over n minus 1, and you take the square root. So I've got the formula in here too. All right, but they're related. It's just based on the sample size. You can correct for that. Okay, so you can do the average by hand or the mean by hand, and you can do the standard deviation by hand. Okay, and that's what I show you how to do. Now, the easiest way to do it in Excel is just to use the formula, okay, which is in the provided Excel sheet. All right. And so the way that you would do it is you would just do something like this, standard deviation population, and you would select all of them. You get that, okay? So that's how I did it. Now, that is a little bit of variation. Here's one with more variation in case 3. So you can see that the numbers get higher, the maximum is higher, the minimum is a little bit lower. And I calculated these all using the formulas, okay? So again, to get the median, you can see the formula in here, but I've got it, you know, in the provided Excel sheet. So that's how you do the average here. You can do the same thing, right? You've got the median, same thing and so forth. Minimum, you've actually got it for the formula here. Show it to you in full. So that's the minimum formula, and the same thing, just have the maximum formula. All right, so that's how you would do it in Excel. And so when you do this, you see like, well, you can just plug it in, you get answers, which is the straightforward way. But if you want to show you how to get this using the doing it by hand way, I'll show you that as well. So one thing to note is that you see that there's more spread, right? That there's more distance from 2. The average is still 2. There's more distance. And you say, well, if there's more spread, the standard deviation is higher. And that is in fact true, right? The standard deviation is higher because the spread is higher, okay? And so again, I did the same thing. 2.8 minus 2 is 0.8. 1.6 minus 2 is negative 0.4. And we know 4 times 4 is 16, and 8 times 8 is 64. These are square. And do the same thing. We sum them up and get the variance when we divide. And then we take the square root. All right, so that's simply doing it by hand. You can see the formula, the way I did it was I did it cell by cell. So to get the sum, I just simply took the sum of the formulas, and then I averaged to get the variance and so forth. So I'll show you that. And so you take the sum from the cell above and then divide. So you don't have to do it by hand, and a lot of times you wouldn't if you're not in a statistics class, but it's really to get a point of these things. Okay, and I'll show you that in a second. I just want to show the last thing, which is the coefficient of variation, standard deviation divided by the mean. Like I mentioned, sometimes like you could have an average of 1,000 and a standard deviation of 100, right? And that seems like a big standard deviation compared to some of these, right? But it's a larger number, so the range is going to be bigger. And so you take the standard deviation divided by the mean. And so 1,000 divided by 100 is 10. Okay. Here you have a fairly small mean and some small standard deviations, and you could take the coefficient of variation as well. All right, and so I did that here. And the coefficient of variation is about 0.2. Okay, so it's this kind of normalizes it or controls for the size of the overall numbers in the sample. All right, large numbers have a large mean. They might also have a large variance, and that doesn't tell you as much. But if you divide by the big number, then that kind of takes that away. Okay, so you could have a tiny number with a standard deviation, and you're controlling for the size of the overall numbers by doing that. So that's a useful measure you might also see, but I kind of am focusing on the 5 here, okay? And so those 5, remember, are the measures of the center and of the spread, okay? So the 2 measures of the center are the mean and median. Mean is just the average. Median is the center point, and that's less sensitive to outliers. When we look at the spread, you can start with the minimum and maximum values, kind of tell you the range of the values. But the mathematical way of doing it is to get the standard deviation. And so that looks at every point's deviation from the mean, squares it, takes an average. Okay, and then that's the second last step, that average squared standard deviation. That's called the variance. You take the square root and you get the standard deviation. So statistically, you can say, what is the spread of these data? And that is measured by the standard deviation. And so if you give the mean and the standard deviation of a sample, people will know what you're talking about. They will know the center and they will know the spread. And then you can say, well, the data are located around this line, and the standard deviation tells you how likely it is to fall in a range above or below. And then, like I said, one standard deviation is pretty typical, like 2/3 of observations will be within one, right? So it's plus, or here it's going to be 100 plus or minus 2, right? So it's not really weird to be 98. It's not really weird to be 102. That is not abnormally high or low. But once you get to 2 or above, then you can say this is extremely high. And then you might, in using statistics, you're basically saying something's going on. Right, so that's what we did right here. Now you can look at the Excel, you can use the formulas for more explanation of what we're doing, but we found the center and we found the spread of data using these 5 main summary statistics.